Yes. Hello, students. Today we are going to discuss about differences between hard and soft computing. So in the last sessions, we have seen what is meant by hard computing, what is meant by soft computing, and what is meant by neurocomputing. So today we want to know the basic differences between the hard and soft computing. So before discussing the discussions, just I want to tell you what is an hard. It is a traditional computing. What is a soft computing? It is a more efficient computing technique which will handle it the real-time problems or complex problems. So the first difference between hard and soft computing. So if you see here, real-time constraints. Sorry. So in the real-time constraints, what we are doing, so if you see, hard computing only works with the real time. Like you say that, suppose you want to work with the prime number. So what is the condition for prime number? So a number which is divisible by its two and itself. Okay. So that is the thing, real time constraint for you. So when we are talking about the soft computing, so this is a real time. So we'll have some constraint which is well defined. So coming to the artificial constraints. So here, if you see the artificial constraints, so you may not have the constraint which is fully defined or which is not exact, or we cannot predict what will be the constraint. So this will be worked only with the soft computing. The second difference, okay, the second difference is about the accuracy. So always in the hard computing, it will be very cautious about the accuracy and precision. But in soft computing, it is very robust rather than accurate. Robust in the sense it will work in any situations. If you change the input or if you change any computational model, it will work. And coming to the third difference, it requires programs to be written. So we have to write the programs. Okay. So if I say what is the logic for the prime number or even number, we have to give the basic program for that. But it will design its own program. Okay, if you're talking about a neural network, it will only create its own network depending upon the input, output, and what are the layers and what will be the weight values. Only will give some, provide some input and will give some weight values. Everything it will manage. And this is followed, the hard computing will follow the two valued logic, means it will have only two logic, either yes or no. But coming to the soft computing, you'll have multi-valid valued logic, means it will have the multiple values. Like you can say the fuzzy logic, example of the fuzzy logic, what you will do, it will take around 0 to 1 values. Okay, so it will take 0.5, it will take 1, or it will take 0, or it can take in between the values. So this is multi-valued logic. And it will require, hard computing will take only exact input data. If you change the input data also, it will not accept. So it should need, if I say I'm giving input as integer value, it will not take the float like that. It should have the exact input. But coming to the soft computing, it can work with any kind of data which is not exactly required, or it can have the different types of patterns. And as we discussed in the earlier sessions, soft computing will work for parallel computations. So it will support parallel processing. But coming to the traditional or hard computing, it will be only sequential. So we cannot divide the task into multiple tasks and distribute among the team, or we can do it parallelly. So it will 100% support the parallel. Next one is it will produce the precise answers, means accurate answers. It will give the value accurately, but here you will get the approximate answers. And finally, it is the hard computing is deterministic, whereas it is non-deterministic, means ambiguity will not be there in the hard computing, but ambiguity will be supported in the soft computing. So these are the some of the differences. We have more differences which we will discuss now. So this is a difference, like hard computing requires program to be written, already we discussed, but soft computing will write its own programs. Yes, two valid logic, and it is multi-valid or fuzzy logic. Hard computing is deterministic. It will incorporate the stochasticity. So it is non-deterministic. On the spot, it will take the decision and it will change according to that. It should have the exact input. It will have the noise or an ambiguous data. Means it will support the ambiguous data. It is sequential, it is non-sequential, and it will support the parallel computations. Finally, it will produce the precise answers and it will yield the approximate answers. Now, so same thing, it will be precisely stated analytical model with a lot of computation time. Okay, so it is tolerant to imprecision and uncertainty and partial truth and approximation. So whenever you are defining the soft computing, always you use these 4 words or 4 terminologies. You have to say that it is tolerant to imprecision, uncertainty, partial truth, and approximation, which is quite opposite to the hard computing. Okay, so it is based on binary logic or CRISP system numerical analysis. So you know binary logic 0 or 1, CRISP systems S or true or false, but it will work on the fuzzy logic and probabilistic reasoning. So it will go for the numerical analysis. Here it will go for the probabilistic reasoning. It has a characteristics of precision and categoricity. Okay, precision means again you will have the perfect clarity and you will have the exact value for that, result for that. But coming to here, it is approximate result and dispositionability. So we cannot divide or we cannot say that this belongs to this patch. Next, so it is deterministic. It is not deterministic. Okay, already we discussed this. It is non-linear, it is linear, it is non-linear. It will produce the exact answers. It will produce the precise answers, like approximate answers. So when comparing all the differences between the hard computing and soft computing, you have to remember the 4 keywords: precision, uncertainty. Okay, next one is your accuracy. Okay, ambiguity, deterministic, non-deterministic, linear, non-linear, or sequential and non-sequential. It supports the parallel. It will only support the parallel computation. Hard computing will provide the accurate answers, whereas soft computing will not provide any accurate answers. It will provide approximate answers. So finally, I'll give you one case study where we can easily identify the differences between the hard computing and soft computing. So if you take an example of human brain, suppose any signal is coming into your brain. So how to analyze, which has not been given before, or you didn't get that particular situation ever before. And whatever you're getting input for that particular processing is not correct, or it may not be complete. Okay. And you don't know what you have to do, or you don't know whether it is correct or not. Okay. So in that case, you can identify it is not deterministic. It is not sequential. It will not give the precise answer, and it don't have the exact input. So how the hard computing will deal with it will not deal that particular problem because it does not have all the requirements where it can create a model. So, but coming to the soft computing, what it will do, because it will support the incomplete data, it support the ambiguous data, and it will won't worried about the precise answer, and it can done parallelly. So this problem can be worked only through the soft computing. So by this, we are going to stop here. So please remember all the differences. I have included more slides because you may get more differences on hard computing and soft computing. So thank you all.